Oh, you like the? All right. Well, let me go on here to my next slide. I'm Schade. I work at DrillingInfo. I'm platform architect. I've been there for a year. I've been doing this professionally for 20 years. I've been writing code for actually more like 35 years. I started when I was 6. I'm 42 now, so this is something I love doing. There's something about sitting down in front of an editor and just writing code and creating stuff and seeing things happen that just, it brings me joy every day, right? It's something I love, I have a passion for. And I say that because this long experience of working with many platforms, many languages over the years, Go has been my favorite language. It's brought a joy back to my programming that I haven't had in years. It's just it's a pretty amazing little language. It's a lot of fun, and you spend many hours a week doing this stuff, and having fun is important. And so I think as an advocate for Go, it's probably the most fun language I've worked in a long time. So that was Dell, eBay. Right now I'm at DrillingInfo, doing some cool stuff with microservices, now Go. But we started out with Scala, and that's kind of what the talk tonight is about. I never wrote Scala before I came to DrillingInfo. It's something I learned there. I've done a lot of Groovy, did some Clojure, a lot of Java, a lot of other languages. I love functional languages, so jumping into Scala wasn't a problem. But the issue, if anybody's had any experience with Scala, is that if you're the only one writing it and maintaining it, it's awesome. If you got to go and maintain somebody else's Scala, there's a cognitive overhead, right, to this language. I mean, I look down, it takes me a minute if I look at some Scala code to understand what's that code doing, right? Oh, sorry. So that's kind of what tonight's talk's about. So I came in there a year ago. They were doing everything with Scala, the Play framework. I've, as an architect at a lot of different companies, you're kind of tasked with helping people make decisions, but you can't on the first day come in and just say, hey, I want to change everything. So how do you influence the leaders of a company to make a decision, to make a different direction in technology? How can you make a compelling argument that what you're saying is actually, going to be valuable and that they're going to listen to you? So, set some early expectations. Your boss doesn't care if you're happy. He doesn't care if the technology you're working with is fun. He doesn't care if it makes your life easier. They care about what's it going to cost them, If this is the wrong decision, am I going to get fired? Is it going to help me meet my goals? And am I going to get all my projects done? That's what the leadership cares about, right? So anytime you're going to try to make any kind of argument to somebody, you got to come at them with facts and data, and you got to take out the personal side of it and say, okay, how am I going to convince you that what I'm saying is in your best interest, right? It's got to be mutually beneficial. So if you're using Go as right now as kind of a hobby, and you want to talk to your team lead or your boss or your CTO and try to get them to adopt it at the company, hopefully maybe some of the tips tonight will help you in moving that forward. And I can kind of do a little contrast and comparison of how I felt that Go served our needs with a microservices architecture better than Scala. The first thing is, who are the deciders, right? You got to find out who's the decision makers. Is your boss the middle manager? Is he a director? Is he the CTO? Who's going to make the ultimate decision about allowing you to use a certain technology at your job? Because those are the people you want to actually start, talking to and trying to influence and convince, right? Because if the guy you're talking to can't make the decision, it doesn't matter. So, how do you find out? All right, first way everybody wins an argument is appeal to authority, right? And this is kind of what we did there at DrillingInfo. I was like, okay, We got lots of companies using this. CTOs like that because it feels safe. Oh, Facebook uses it. Google uses it. All right, this is kind of proven. This isn't going to be some crazy one-off, like Clojure. I'm a big fan of Clojure. I love it. Awesome, another fun language, but no one's using it, and gonna have a hard time convincing a company to go with that decision, right? Go has tons of support, so kind of appeal authority. Lots of companies using it, lots of big companies. Next big thing are, hey, all the tools that we work with day in and day out, these our favorite tools, these are built in Go. Docker, Console, Couchbase, many more. I mean, there's a lot of tools that we use at DrillingInfo, and I was like, hey, why don't we go look at their Git repo? These things are written in Go already. And if we hit a snag or we want to figure out how to do something, especially when you're working in distributed systems, like what's the best pattern, we've got some pretty good, solid Go code bases to look at and see, okay, what are the best practices and how can we do these things? And since most of the people like these tools that you're working with, they're like, oh, we love Docker, we love Console, kind of eases that decision, kind of warms the field up for them. So Scala at DrillingInfo. When I got there, it's a microservices architecture, which is, I think the right architecture. I've been seeing this evolve over, a couple of decades, and I think it makes a lot of sense. We have a hybrid cloud. Half of our stuff's in AWS, half of it's in on-premise data center we have. Mostly we were using a Play framework when we first started. Play framework was a little bit heavy because we're just doing services. We don't really have to worry about rendering UIs, rendering, web pages and stuff. So we kind of did a couple experiments to see, hey, maybe Spray IO would be a little bit lightweight and it'd be a little bit better. The thing we kind of run into is we have a handful of really good Scala programmers, and we have some people that come from maybe they're really strict Java, or maybe they don't have a functional background, so they're you can write pure Java in a Scala file, it'll work, right? So you get multiple styles, and kind of going back to what I said earlier about Scala's concise, but sometimes it's a little too concise. You can't, unless you've been doing this and you understand, kind of all these little functional paradigms, you can't look at a block of code and immediately just say, oh, I know exactly what this is doing. And the Scala that I write, and the Scala that you write, and the Scala she writes, is probably going to look a little bit different, And it's hard to have like a team continuity. Like, I got to go work on your stuff or fix your bug. All right, now I got to figure out, all right, how did you write this? So there's just a lot of, in my opinion, there's a lot of cognitive overhead, and there's an impedance mismatch between what's this code doing and what's this code supposed to be doing. And that was one of my issues. I went in with open mind because I like functional programming. I had no problem doing the Scala. It was fun. I actually rewrote a couple of the services because from scratch I was like, yeah, this is, if you're going to make me maintain this in production, then either I'm going to rewrite it or somebody else is going to work on it. Just because it's easy to go down some pretty crazy rabbit holes with Scala. Kind of example of Scala versus Go. Like I said, it's very concise, right? If you hear all this little block of code is going to do is, hey, let's go grab a cookie and validate that the value in that cookie's a number and it's greater than 0, and then it's actually there, right? And so yeah, first line you got 4 lines of code, but you got to know, okay, well what's the what's the map? I know what get is. Okay, I can sure that's going to get me the UID. What's map going to do? All right, it's probably going to try to apply something on something. What's this underscore mean? And then filter underscore again greater than 0. Unless you have this implicit knowledge and you understand, if you've read the Scala spec, it's 800 pages. Right? If you read then you got, see, I know the Scala spec, 800 pages, or no, 600 pages for Scala spec. Java 8 spec is like 800 pages, right? Go spec is 56, right? There's a lot of implicit knowledge you have to understand what are all these different symbols, what do they mean in different contexts. And that's my biggest gripe with Scala, is that there are 10 ways to do everything and all 10 are probably right. And it frustrates me. Like, Clojure or Haskell, it's very consistent. There's a couple of very similar ways that you do everything. And I like that. I want to know that, I like consistency. I want to know that the code that everybody writes looks the same, does the same thing, so I can work on your code, you work on my code, and there's no issues. That's why I love Go. I mean, Go format, you don't have to worry about how stuff looks anymore. It's just going to look the same way. You can write a program in Go, and I'll write a program in Go, and there's a good chance about 90% of it will be the exact same. And that's kind of nice. Actually, I didn't go off. So yeah, the other big thing is there's more lines of Go code there, but this is very explicit, right? It's explicit to a fault, and it makes it super easy to read. Anybody can go down and look at this. It's very procedural. It's very line by line, and understand what's happening there. And I don't have to really know much. All right, I'm going to get a UID from a cookie. I want to parse an int. Okay, it probably needs to be a number. Is this value less than 0? Okay, that's invalid. You don't need an expert level person to read that second line of code. That first section, unless you've got a lot of experience, you're not going to just get that off the bat. I bet 8 out of 10 people are going to look at it and like, okay, I got to go look. I probably have to Google some of it. So, and that was one of our complaints, because we have developers from all kinds of different backgrounds. A lot of them come from doing JavaScript and working on kind of front end stuff and wanting to work on some of the back end services. And you try to take or they're newer people that have a couple years experience. You try to take them into the deep end of the Scala pool and just throw them in there. It's not going to be a pleasant experience, right? They're going to have a harder time. And then it's going to, it slows down everybody else, right? I have to do more code reviews, I got to do more help, or he's got to do more help, or she has to do more help. The team velocity I saw would slow down as we brought on new team members. Totally opposite with Go. My boss, director, very good technical guy, still writes code too. Got him writing Go services. Had him trying to write some of the Scala or fix some bugs in the Scala services. Hard time. He'll even tell you, he's like, I don't understand it. I look at it, I can't read it. Go, no problem at all. So we've had people from the DevOps team to CM team to QA just be able to look at stuff and do it. And that's what I like about it. So, other than the code being, easier to read, it was like you got to have a good value proposition of why would you use Go versus Scala. So, like I said, we're in AWS. We have lots of instances. So I did a quick proof of concept. I took two of our services. Both are simple CRUD services that read from Couchbase. They're little microservice REST APIs. Our Scala service was 350 meg image size. Some of our other Scala services are about 500 meg image size. This is using Alpine. Go services right now, they're all between 5 and 15 meg. And you're like, oh, well, who cares about image sizes? But when you're doing Docker push and Docker pull, and you got your Jenkins jobs, and you're doing builds, and you're pushing up, half a gig. It's not like 2 seconds, right? It's this Scala build takes 4 minutes. This Go build takes 40 seconds. That makes a big difference. And if anybody here, how many Scala people here? Anybody use Scala professionally? No? All right. Awesome. Well, hey, you don't know the pain until you say like SBT test, right? And I want to run my tests. And it is 40 seconds to a minute and a half to run my test. That's That's an eternity, right? You run Go tests, right? And it's milliseconds. I mean, how many people does your test? I've got some suites that are like hundreds of tests, and even including benchmark tests that run 50 times each, and it might be 2 seconds. If I put cover and race on there, 4 seconds maybe, but they're doing a lot more work, right? But not, a minute. And that's like, I just want to take this laptop and I want to throw it against the wall. A minute and a half, I want to go home. This is like it's compiling. Let me go get some coffee. That's ridiculous. That's like I started out as a mainframe programmer. It's kind of hard to believe, but it's, we'd submit our jobs to the compiler. It'd be, okay, tomorrow, check on and see if it's actually finished. That's what it felt like with Scala. And that's just like running tests. And then the builds are minutes. So just the encumbrance. And so being able to pull up a simple text editor and have your terminal open and just run Go test and Go build and Docker, it's just so much better. Memory, so yes, size doesn't really matter. Okay, it's a little bit. It takes time to push that across the network, but memory is big, especially if you're going to AWS, you're buying your services, your servers, paying for them every month. We use 5 to 25 meg per service in Go. We had to allocate at least 512 meg per Scala service. Some of them are a gig but it's always a minimum of 512. And you could probably get fancy and try to cut that down a little bit until you get the, out of memory errors. So that's still a lot, right? And that's going to cost you money. We use C3 2X larges, right? They're 8 CPUs, 15 gig RAM. We could get, theoretically, you wouldn't want to do 30 Scala services on a host. We'd probably do more like 15 to have some buffer there. We can get 10x the number of services and Go easy. We could actually probably be ridiculous and get 20, 30, 40x the number of services per host. And when your AWS bill comes every month and you see it growing as you keep building new and new services, we have 40 services and then 50 and 60. That is you can take that to the CTO and say, hey, look, you're gonna, instead of us buying new hosts every month, adding new instances, you're gonna have the exact same runway that you have all year, because we know that this is all going to scale. They're all going to fit in the instances we have, and you're not going to have this crazy growth in your AWS bill. CTO's going to be like, all right, I'm on board. Here's some of the things that, like I said, I couldn't just come in the first day and say, hey, let's change everything. That'll never work. Like I said, no one will listen to you. You got to kind of feel their pain, come in there, feel the waters out, warm people up, get some credibility, and then bring some real data like, okay, here, this is how we're going to save money. This is how we're going to scale. This is how we're going to be quicker. This is how we're going to, do things with less and be more efficient. This is from Facebook. I thought it was fun. I did a hackathon with Facebook last year, and they all had these shirts saying "Code wins arguments," and I was like, that's an awesome little saying, because when it comes down to it, anybody can talk bullshit, but at the end of the day, code is what's going to determine it. All right, you can tell me all your philosophical and academic theories about this and that, but I'll show you some code, and you show me some code, and then we'll look at the result, and then see who wins. Right? So if you want to try to convince your team, you gotta show something. You gotta put a little work in there. So the first thing I did with Go, first thing I did was I wrote a little command line interface. Go is awesome for writing quick CLI apps. Actually, the fastest thing I've ever had to write CLI apps. And we had to migrate a bunch of documents from one Couchbase cluster to another and do some transformation because it can be in a different JSON format. And Go was perfectly suited to this. It took me a couple of days to write this little utility. There was no risk to it because it's not going to go to production, right? This is just a tool that our CM team was going to use to help with this migration. So there was no big worry about, okay, well, who's going to support this? Who's going to, how are we going to deploy it and configure it and do all this other stuff? And these kind of little examples show value, right? It's a good way to kind of whet the appetite for the people that you're working with. So like I said, I wrote this little command line tool and said, okay, this is how we can use Go. And it worked really well, and a lot quicker than some of the other solutions we were thinking of doing, minimal investment. So that was kind of like step one. Step two was, all right, now I've kind of talked to the bean counters. Now I need to kind of win. This is like a special forces type thing. I need to win the hearts and minds of my developers, right, and the teams, and get everybody else on board of how are they going to want to do this. And there's a couple ways to do it. So first off, make it easy, right? So we had this issue. We had a new kind of president come in, and he was like, he had a background in technology, but he was like, I really think we should be doing Java Spring. And I was literally like, fine, I quit. I got better things to do. I'm not doing Java Spring, but good luck with that. Because no way. And so, but he and another director, they were like, hey, we don't know if we should be using Go. Let's take this to the Architecture Council. And let's, bring your arguments. We'll see if we should make this decision. And I was like, crap. All right, how are we going to win this little argument? So I'm watching Bones with my wife. I don't really like the show, but P's got to make the wife happy, so I'm watching it with her. And so it's an hour long. As we DVR, so it's actually more like 40 minutes. So I'm like, you know what? For a service, before we can deploy a service to production, every service has all this boilerplate. And I'd already written a couple of Go services, and I wanted to get other people and other teams to write Go services. But all of our services have the same kind of requirements. We have a set of admin endpoints that every service has to have, for health checks, version, and metrics. Every service has to have this Jenkins YAML in there, right? How do you do the jobs report requests and all that stuff? So it's like, you know what? I'm going to just create this really quick generator to generate all the boilerplate for code that gives you all your admin health checks, gives you, tests on everything. So if somebody's brand new to this language or brand new to our platform, they want to, hey, how do we create a platform that we can deploy out there tomorrow? Then you can do this thing in, seconds. And really, it got to the point because this is like my third service, and the hours that it would take to copy all these files and change these files and type all this stuff in, I was like, this third time, it's like, I'm not going to do it again. Right? I'm just going to just generate this from now on. And I was like, you know what? It's also another way to kind of win by fiat. So we had a lot of services that were required for this really important project. And I wrote this generator knowing that I could talk to these different developers on different teams and show them and get them a service running in minutes, versus them taking, days or weeks or whatever. Like you write your Scala service from scratch. Okay, maybe 2 weeks you might be done. Okay. Here, I literally sat down with one of the developers from Denver. He didn't have Docker installed. He didn't have Go installed. And he had a service, and he got a ticket to build this data service. We had the shell of his service working, and including installing Docker and Go and all that, in 30 minutes. Using this little generator, and I say demo because I'm a little scared of doing demos, but I can show you guys some of of what it is and how easy templating and stuff in Go is, if you're interested. But I did it with him. I did it with a bunch of other people. Got a lot of services out there deployed, and so then when we came to the Architecture Council, we're like, well, we already have 12 of these Go services out there. I mean, do we want to we're going to rewrite those? Are we going to stop those? So, I mean, a little dirty trick, but sometimes winning by fiat works. People have deadlines. They have, pressures. It's a way to kind of get your way. So you can be really fast with Go. Let me see what I got here. I think that was my last one, but.
Didn't you guys produce 14 services in 2 weeks or something?
Yeah. And I mean, when we say service, a lot of these are like basic CRUD services. If you look at your services, you're going to talk to some data source. You're going to have some endpoints for doing, your puts and posts and your gets and your deletes and stuff, right? I mean, overall, the logic is very similar, right? There's not a lot of rocket science involved, so you can literally generate most of your stuff and then spend time working on some hard problems, right? Which Go is perfect for. Concurrency. You ever do some concurrency? I was showing, this is Richard. I was showing Richard, about concurrency. He's like, what do you love about it? And I showed him this little set of 3 functions we had. There's like 30 lines of code. Allows us to go and send off, up to 1,000 concurrent processes. They can all run, independently and all write back to some shared memory safely, right? Using channels. And it's 30 lines of code. It's easy to understand. There's not rocket science. And it's like, that is powerful with Go. It's not like some powerful voodoo, special code that Sean wrote that no one else can write. It's something anybody could write. And that's what the power of Go is. Like, they make this stuff easy to approach, easy to understand. So that's it. Any questions?
Got a question.
Yeah.
So I'm picturing that you had a team of, a number of Scala developers. Did anybody ever come up to you and say, well, X language has more features than Go, and how did you counter that?
Yeah, we actually, it was kind of fortunate because, like I said, I think a lot of the team members that were there came from more of the JavaScript background. We were kind of being forced into the services world. The platform team, my team was pretty much writing most of the services. And then as demand increased, we had to get other people from other teams to write their own services. And so a lot of them, when they first hit Scala, really did not like it. There were a handful of people that were there earlier that did like it, and there were a couple of us on the core platform team that were pretty proficient with it. But there's a lot of ego, and it's even hard someday. I have a hard time right now saying it. Right? There's a lot of ego when you come look at something like, I've said I've been doing this for 20 years, but Scala is hard to understand, right? There's some ego from any developer to say, oh, no, I don't understand that. I'm afraid to say I don't understand this. It is not easy to read Scala. It is not easy to work in Scala, It is one step removed from Haskell. And Haskell's a lot better. It's like all the negatives. So when they say, like, what are all these features missing? I didn't really get that. It was more like, oh, man, you just made my job a lot easier. Like, I don't have to sit here and figure this out. Now, we could talk to, like, some hardcore functional programmers, and they probably come in. I mean, I missed map and filter and all those things in there. I kind of missed generics, but you gotta approach everything with what they call the beginner's mind, right? Anytime you come to any new topic, right, you come with like, hey, I'm a complete beginner. There's no ego here. I'm just going to approach this like I don't know anything, right? And that's what I do with every language. I don't know Go. I'm going to do Go the Go way, the Go idioms, just like Scala. I'm going to do Scala the Scala way, or Clojure the Clojure way, right? You got to go into it with that approach that, I'm going to take this and just, I guess the saying is that it's hard to fill a cup that's already full, right? So if you think you know everything, you're not going to learn anything. And you got to approach this with, I know nothing. What can I learn here? What can I learn from you? What can I learn from this language? And I think if you do that, I think picking up any kind of new technology is easy, right? You just got to be willing to kind of set aside the ego and say, okay, maybe I don't know everything. Maybe I'm not the expert in this field.
So can I ask
Yeah.